All right, so in this first problem, we are given some information, and even though we're not explicitly told to, we need to put this information into an equation so that we can select the correct answer choices. Our answer choices are given to us in a little bit strange format because two of the answer choices are graphs and two of the answer choices are input, output, or function tables. So I need to create an equation because that's going to help me figure out which one is correct. So even though it doesn't explicitly ask for it, we still need to go ahead and plug this information into an equation. All right, so we're told that Y is the total number of toys in his toy box, and that X is the number of months that have passed by. So we're going to put this information into this Y equals mx plus b format. All right, this is going to be pretty standard for this particular objective. So the first thing we need to know is, or we can start anywhere, but I'm going to go ahead and start at the end because I think that's probably the easiest. So this b value, this is our y-intercept value. And for most scenarios and situations, it's whatever you're starting out with. So the reason why is if you can imagine the starting point, the m is going to be 0. All right, because our starting point for x is going to be 0. So it's whatever you're starting with before you ever even begin. And so in this case, our starting toys are 15. So before anything happens, before any toys are added for any months at all, we're starting with 15 toys. Okay? Now, the m, that's our slope, that's our rate of change. Our problem tells us that 2 toys are added each month. So that ends up being our rate of change. Is every month, and remember m, our month is notated, our number of months is notated by our x value. So every month we're adding 2 toys. That's our rate of change. All right, so our m value is 2. So our equation ends up being y equals 2x plus 15. Now we have to look at our answer choices and figure out which answer choices match this particular equation that we've just created. So when you look at the function tables, you're given several values, and they're kind of oddball values. So I'm not going to go through every single value in the function table. I feel pretty confident that you can go through and you can plug those values in. So you're given the value for x, you want to plug the value for x in, solve for y, and see if that's the correct value for y. If you find a mistake or an error, that's probably incorrect. What I want to focus on instead is the graphing piece of it. All right? So the graph, what it should look like, and we'll be in quadrant 1, because since we're dealing in a real-world situation, the kid's not going to have a negative number of toys. That's a little bit ridiculous. You're not going to see that kind of scenario. Could you see negatives in a real-world situation? Absolutely. When you're talking about money or sea level, there's a lot of scenarios where you could see negative numbers in a real-world situation. But here we're in quadrant 1. All right, so I'm just going to draw a quadrant 1 xy. So here's my y, here's my x. All right, the starting point for our line is at 15. That is where x is 0, y is 15. Just like we talked about earlier, the reason why our y-intercept is 15 is because when x is 0, when our months are 0, that's our starting point, then y will equal 15. But now I need to get a few more values in order to plug in. And what I'm going to go ahead and do, I'm going to pick 2 values from the data table, and this will kind of give you a little bit of a hint on those as well. So I'm going to pick 4 and 6 for values to plug in here. So we're going to do if x is 4, then we get y equals 23. And then if we have x is 6, then y is going to be 27. So when I'm plotting this, I'm just going to go ahead and pick an arbitrary point out here to be 4 and 6. These aren't really spaced in any particular logical way. And then I'll do 23 about right there. do that kind of small. So I'll have a point here, and then 27 is going to be a little bit higher up, and a point right here. And so my line's going to look something like this. And it will be a line. It will be a straight line. So as I look at the answer choices that are given, you want to select either a graph that follows this pattern, or if you can find an input or output table, or an input-output table or a function table that also has the correct values. Pause the video, work it out, and then I'll confirm your answer in just a moment. So if you picked answer choice B, then you are correct. And the reason why is because the B graph is very similar to the graph that we've created. Now, you should have been able to eliminate A as an answer choice whenever we plugged in 4. And you should have been able to eliminate C as an answer choice when we plugged in 4 as well. So, and you also confirmed it when you plugged in 6 into A. What makes D wrong is that it doesn't account for the y-intercept at all. It just completely ignores it, and it starts the line at the origin. Well, the line doesn't start at the origin because we have a y-intercept of 15. So our correct answer is B. So in this problem, we are given a data set. We're given a function table, an input-output table, where we have values for x and values for y, and then we have to construct an equation based upon these values. So we're not actually solving for a value so much as we are constructing an equation that would match these values. Now, one thing working for us in this particular scenario is we have an x where x is 0. That's going to be really helpful in just a minute. So as you can see from our answer choices, we're working in this y equals mx plus b format. All right, so the y is going to stay y, the x is going to stay x, and we just have to figure out what are our values for m, which is our slope, our rate of change, and what's our value for b. All right, so b is our y-intercept, and the reason why having this value for where x is 0 is so helpful is that just gives us the value for our y-intercept. Because if x is 0, that means that no matter what this is, what this m is, if x is 0, then basically we're going to be left with whatever b is, because anything times 0 is 0. So in this case, we know that b is 5, because when x is 0, y is 5. So we know on a graph, our y-intercept, the x value would be 0, and so the y value it's telling us would be 5. Now comes the slightly more challenging part. We've got to figure out what our slope is. All right, and we figure our slope by the change of y over the change of x. All right, so remember, slope, our rate of change, is the change in y over the change in x. All right, it's our rise over our run. All right, so it actually, when we're given the data in this way, it actually doesn't matter which values we pick for y or which values we pick for x. We're going to go with what I think is probably the simplest computation-wise. We're just going to take these top 2 points. And then we can verify later once we check our equation with the points that are given to us on the bottom where the values are a little bit larger. All right, so for our change in y, remember that's going to be y2 minus y1 over our change in x, which is x2 minus x1. So in this case, our y2 is going to be 7. Our y1 is 5. Our x2 is 6. And our x1 is 0. And so we're left with 7 minus 5, which gives us 2, over 6 minus 0, which gives us 6. So 2/6, and then we're obviously going to simplify that into 1/3. So my slope is 1/3. Now let's verify that with our other values here. All right, so if x is 12, 1/3 times 12 plus 5. So 1/3 times 12 would be 4, because we'd get 12 thirds and then simplified would be 4. So y equals 4 plus 5, which gives us 9. All right. And just for the sake of consistency, even though I'm almost out of room, let's do it down here. If x is 15, what would y be? So 1/3 times 15 be 15 over 3, which would be 5, plus 5 is 10. So we verify that this is, in fact, the equation for this data set. So in this problem, we're once again given a data set of x and y coordinates, x and y values in a function table, and we're asked to construct an equation, a y equals mx plus b equation, that would match these values. So once again, we're quite fortunate because we're given, if x is 0, what y would equal. So 1.5, we know, is going to be our y-intercept. And now we're really just left with finding what is our slope value. Now, these numbers are going to be a little bit, well, they're not too challenging to work with. So remember that to find our slope, it's the change in y divided by the change in x. All right? And remember, to find the change in y, we're going to subtract y2 minus y1, and then divide that by the change in x, which is x2 minus x1. And again, when we're looking here, it doesn't really matter which pairs we use, but I'm going to do the simplest that I can find. So I'm actually going to use, I think I'm going to use these two values right here. All right, so this is going to be my x1, this is going to be my x2, this is going to be my y1, and this is going to be my y2. And I think you'll understand why I chose these values in just a moment. All right, so my y2 is 4.5. My y1 is 1.5. My x2 is 1. And my x1 is 0. Hopefully you figured out why I chose these numbers. All right, so 4.5 minus 1.5 gives me 3. And 1 minus 0 gives me 1. So my slope is 3. Now I can verify that if I would like to, and I think I'll verify it with this one, with this when x is 2, y is 7.5. We'll just do a quick check of that. So y equals 3, x is going to be 2, plus 1.5. I'm just plugging x into my equation that I've created here. And so we get y equals 6 plus 1.5, which is 7.5, which is what I have here for y. So my check is good. So in this question, we're given a real-world scenario where we're trying to calculate the total cost of a desk repair. So y is going to be our total cost. X is going to represent the number of hours that this person's brother works. And then we're left with trying to fill in the values for our slope and our y-intercept. And then once we have those values, then we can verify and see which one of our data tables is correct. So we know right off the bat, that our y-intercept is always going to be, our b value is always going to be the value when x is 0. All right, so if we look at this and think about it, if this guy's brother doesn't work any time at all, then he's not going to get paid. But the materials have already been purchased, so that material cost is never going to change. Whereas the brother's payment is going to be determined by how many hours that he works. So in this case, our material value, which is $485, that is our y-intercept. And if you think about it, that makes a lot of sense, because if the brother never works a single hour, if there's 0 hours here, it doesn't matter what we decide the value is for our slope, this number will be 0, because it'll be just 0 for x times whatever this number is. That's going to give us $485, because that's how much this guy John has already spent. Now we got to figure out, what is our M value? Well, that value is how much we're paying the brother per hour. And when you hear per hour, per second, any type of per something, then that is pretty explicitly your rate of change, your slope. All right. So in this case, we have $25 per hour. So our equation is y equals 25x plus 485. And now it's just a matter of plugging in the values that are in our data table. And thankfully, they're pretty gentle in that they give us 0, 3, 8, and 12 as our x values for all 4 answer choices. All right, so what I'd like you to do now, pause the video, see if you can determine which one is correct, and then we'll verify that your answer is correct in just a moment. Okay, so hopefully you've got an answer. You've already done all the computation, and now we're just double checking. Now, the good news on this is we can eliminate answer choices G and J immediately, because they've got if x is 0, y is something other than 485, which doesn't make any sense. Like, this brother's not getting paid if he doesn't do any work. All right, so if x is 0, then 25 times 0 is 0, plus 485 gives us 485. So we know right off the bat that when y is 0, x is 485. So we're just left with f and h. And we'll just use 3. So when x is 3, 25 times 3 plus 485. So 25 times 3 is 75. So we get y equals 75 plus 485. And then we're just left with 485 plus 75, which gives us 560. So when x is 3, y is 560, and that leaves us answer choice H. Now, could you go ahead and verify for what the value would be for 8 and 12? Absolutely. And if you've got a calculator handy, punch that in. Should take you, snapper's not working, should take you about that long. Remember though, fundamental to this, you've got to construct this equation first. Because without the equation, if you're trying to do these computations in your head, and especially if you're doing them on a calculator and you're not writing all this down, you're just setting yourself up to make a mistake. So in this question, we are given a data table. We're given a function table, an input-output table with our x values and our matching y values. And then we're asked to select which graph accurately represents this particular function table. Now, we could, theoretically, just find these points and look on the graph and see which graph all these points create. But I think a better strategy is to go ahead and create our equation, our y equals mx plus b equation, and then that should make things hopefully a little easier and a little bit more accurate. And I think what we're going to find with these numbers is they're relatively easy to work with. So let's start with, and we're quite fortunate because we're given when x is 0, so we know that our y-intercept is going to be 5, because when x is 0, doesn't matter what our slope is, when we multiply that by 0, that's going to give us 0, and then we're just left with whatever the y is. So now we just have to figure out what is our slope. And remember, our slope is our change in y divided by our change in x, which is y2 minus y1 over x2 minus x1. And I'm going to pick some values that I think will be a little bit simpler to work with. I'm going to pick this one as my y1, this is my y2, this is my x1, and this is my x2. And I think you'll be able to see pretty quick why I chose those values. So my y2 is 6, my y1 is 5, my x2 is 2, my y1 is 0. And so what I'm left with is 6 minus 5 is 1 over 2 minus 0, which is 2. And so I have a slope of 1/2. All right, now we've got to verify that this is in fact correct. Okay, so We can plug this back in if we would like to, and that might not be such a bad idea. So if I do just a real quick check, I'm going to use this one right here to check, so I don't have to mess with the negatives or anything. If I say that when x is 5, y should be 7.5. So let's see. If I put x here, that's 5 times 1/2, which is really 5 divided by 2. So 5 divided by 2 is 2.5. All right? 2.5 plus 5 is 7.5. So just a quick check. Yep, I'm good. All right, so here's my equation. Now I need to find a graph where the y-intercept is 5 and the slope is 1/2, which means the rise is up 1 and the run is over 2. And I should be able to point that out very simply. So pause the video, see if you can find which graph is correct. Once you've selected your answer, unpause, and we'll verify that you got the correct answer. All right, so we can immediately eliminate D because the y-intercept wasn't 5. For A, B, and C, though, it does have the y-intercept as 5. So let's look and see if we can determine which one has a rise of 1 and a run of 2 for that slope. And it looks like A, because if you look at the next good clean line, take a look at point 2.6. So point 2, and when I say 2.6, I don't mean 2.6, I mean where x is 2 and y is 6. That's the next point. And it's actually, hey look, it's right there. So what about 0.5? Well, 0.5 is there as well. So the rise and run makes sense. So our answer is A.